All right. So plank A to E, that is length 6 meters. It's given in the diagram. Weight 100 Newton. So is it uniform or non-uniform? Is telling as a uniform rod. Uniform rod means we have to assume at the center. So let's say this point is M, and downward force 100 Newton is the weight of the rod. Rests in horizontal position, supported B and C. So at B we will get support RB, reaction RD and RB. AB is 1 given in diagram. DE value is 1.5 also given in diagram. A child of weight 145 Newton. So this is a child here standing at 8. So his weight is 145 Newton. The midpoint of AE. Okay, the child is also standing at midpoint. The child is also standing at midpoint. Okay.
Yes.
That means this force will also be at the same place. Okay, we need not take a separate point M here. Okay, so both forces are acting at the point C, 145 and 100 newtons. The child is modeled as a particle and Planck as a uniform rod. The child and Planck are in equilibrium. Calculate the first bit, magnitude of force exerted by the support on Planck at B. So RB we have to find. So in order to find RB, we have to take moment about which point? Moment about D point. Okay.
Yes.
Take moment about D point and do it. So 100 and 145 both are at same place. So we can add them together. And distance from D is CD. This is moving in anti-clockwise direction, so plus. Then RB distance is BD, and this one will move in clockwise direction, so minus. These are the only two forces acting, so total should be 0. Now CD length, you know.
Yes.
So this is 6 means 3 minus 1.5 will be left here. The CD length is 1.5. Then BD length is B to D. B to D will be 6 minus both these values. So 6 minus 1 minus 1.5. 6 minus 2.5. That is 3.5 now.
Yes.
So substitute both these values. Send that term to the other side. 100 plus 145 is 245. Into CD is 1.5. Other side we get RB into BD, that is 3.5. So RB value will be divided by this. Let's take calculator. $105. Okay.
Yes.
So this is the reaction at B. So A bit solved. For B bit, let's take a different color. B bit, what is he asking? The magnitude of the force exerted by support on the Planck at D. So he's asking RD. In order to find RD, let's take sigma V first, then substitute the value of RB in it. We will get it. So RB is acting upwards, RD is acting upwards, 100 is downwards, 145 is downwards. So total should be 0. This implies that RB plus RD will be 245. Then substitute this value in here. So RB value we have to substitute. So RD value will be 245 minus RB 105. So 1 40 newtons, right?
Yes.
So B bit is also over. Now the child now stands at a different point F on the plank. The plank is in equilibrium and at the point of tilting about point D. Calculate the D distance df. Now the child will shift to a point F, and when he shifts, it is tilting about the point D. Okay, if he is tilting about point D, he has to shift here now, F. So this 145 will shift to here. Okay.
Yes.
So when it reaches here, it is tilting. If it is tilting, this becomes 0, and this is the information we have to use. So let's go with C. So yes, C bit. Calculate df. Df length, let us take it as x. Now we have to take moment about D point. Moment about D point. Give me a minute.
X.
Hello. Hello. Yeah, so MD, take moment. RB has become 0, neglected. 100 Newton. What is the distance? CD. 100 into CD, that is moving anti-clockwise, so plus. Then 145 into DF. This one is going clockwise, so minus. That's all. There are no other forces acting, so total 0. So now CD length is how much? CD length is known, 1.5, and DF length is x, correct?
Yes.
So we just need to solve it. So 100 into CD is 1.5 minus so this term, send it to the other side, 145 into x. That's it. Solve it and you will get. So 100 into 1.5, 145, 1.03. Distances are in meters, so keep it in meters. Okay.
Yes.
Any doubts here?
No, sir.